Well, hello everybody. It's me again, and this will be Tuesday's lesson, and for AP Chemistry. And this is actually we're going to be talking about percent composition. And yesterday, meaning Monday, you had worked on going from grams to moles and moles to grams, and hopefully you found that to be very straightforward and rather easy to do those calculations. I certainly hope so, because they're not meant to be difficult. It's just, like I said, merely using the periodic table and doing some conversions back and forth. So today what we're going to do is we're going to begin talking about percent composition. And you might say, okay, what's that all about? Well, it's again, none of these topics, I think really, when you start digging into first year chemistry, it's really not that difficult. A lot of it's sort of common sense. Um, Percent composition just means like a regular percent. It's the part over the whole times 100. That's percent, no matter how you slice it. And we can look at some examples here. In a chemical compound, let's take a very straightforward example. And we'll come back to this example on the right-hand side of the screen in just a moment. If I have H2O water, we know we could easily figure out that this is 18.02 grams per mole. You can do that in your sleep by now, hopefully. 16.00 for oxygen, 2 hydrogens, each at 1.01 grams. And so the mass of molar mass of water is 18.02 grams per mole. Now, what percent of water is hydrogen? Well, let's think about this. I've got 2 hydrogens at 1.01 grams per mole, and I divide that by 18.02 grams per mole times 100. And of course, my units cancel out. And you come up with an answer. Do it on my calculator here. 2 divided by 18.02 times 100. I get 11.1% of water is hydrogen. Well, let's figure out what it is for oxygen. There are 2 ways to do this. There are only 2 elements, so we could just subtract 100 from that. 100% minus 11.1, and you should get 88.9. But let's do it mathematically. So we're going to have 16.00 grams per mole. Okay, this is hydrogen. 16.0 grams per mole divided by 18.02 grams per mole times 100. Oh, sorry about that. I don't really like this pen that much on the whiteboard. So we get rid of our units and we divide 16 divided by 18.02. Oops. And we get 88.9 percent. Now that should add up to 100. So I'm going to add 11.1. Hang on. 11.1 plus 88.9. And sure enough, that adds up to 100%. So that's percent composition. And when I get back, when we do our lab, this is going to become important. Percent composition. There's nothing to it, really. Let's take a look at this example. Steps to solve for percent composition. In this case, you have a chemical formula, PCl5, phosphorus pentachloride. Don't forget how to name these chemical compounds. Well, step 1, find the molar mass of all the elements of the compound. We've got 30.974 grams for a phosphorus. Just look at your periodic table. 5 times 35.453 grams of chloride, of chlorine, and that multiplies out to 177.265. Adding those together to find the molecular mass, well, you've got molecular mass here of 2.08, excuse me, 208.239 grams. And then, in order for us to go ahead and get the percent composition, it's just a trivial calculation. You have one phosphorus, and let's see if I can change my pen to a highlighter here. There we go. You've got the one phosphorus right here, and made it a little bit bigger so you can, I thought you could be able to see it. I never have luck with these things. Well, let's just take a look here. If you take a look over here, we have one phosphorus, and we know it's 30.974, and we divide it by the whole molar mass, which is 208.239, and we get 14.87% by mass. Phosphorus pentachloride is 14.87% by mass phosphorus. Now, we only have two elements involved here, phosphorus and chlorine. So we could just take 100 minus 14.87, and we could get that 85.13 right down there. That's no big deal. But if we have a different chemical compound, like let's say, for example, we have CuSO4, well, you'll have to do it, you have to get at least two of the percentages before you could go ahead and subtract and get the last percentage. Matter of fact, this is one that we're going to be playing with in just a couple of minutes. So here's another way that you could look at a problem. If you don't know, see up here, we knew the formula of the compound. We knew PCl5, or over here, we knew it was H2O. We knew the formula for each compound. But in this case here, we don't know the formula for each compound. So we are going to go ahead and get the percent composition. Now I should give you a heads up. We are learning percent composition in order to work backward to find formulas of chemical compounds. After we learn about grams per moles, moles per grams, and percent composition, we're going to discuss something called empirical formula and molecular formula. And so we are going to be able to use percent composition in order for us to get the formula. Let's say we go into a laboratory, we make a brand new chemical compound, and we sent it away for what's called elemental analysis. They'll come back and they'll say, hey, in a 12.04 gram sample of a liquid compound composed of carbon, hydrogen, and nitrogen, it's shown to contain 7.34 grams of carbon, 1.85 grams of hydrogen, and 2.85 grams of nitrogen. What is its percent composition? Well, pretty straightforward to do that, because again, percentage is always the same thing. It's the part over the whole. So, let me get my pen back here. I'm going to try changing the thickness a little bit. So let's take a look at this. Now, how would we go ahead and do a problem like this? Well, we're going to get the percent composition. So first of all, we are told it is 7. Oh, I don't like that thickness on that pen. That's a little too thin. Oh, man. Come on. Come on, man. Okay. Going back to my pen. So we have some chemical compound. It's made up of carbon. It's made up of hydrogen. And it's made up of nitrogen. And we are told that we've got 7.34 grams of that sample is carbon. I'm going to divide it by my total, 12.04 grams. I'm going to then do the math. 7.34 divided by 12.04 times 100. And when I do that, I go ahead and I get, oh, mamma mia. Sometimes Microsoft products just are terrible. Oh, where's I don't even know where my math is now. Let's redo it. Okay, so I've got 7.34 grams of carbon divided by 12.04 total grams times 100, and that gives me 60. If I this is what I get on the calculator: 60.963%. Okay, 60.963%. Let's carry those digits out for a little while and see what we get for the rest of them. And then we've got 1.85 grams of hydrogen. And I'm going to go ahead and divide that by 12.04 grams times 100. So 1.85 divided by 12.04. And I get, when I go ahead and do that, 15.365%. 365%. This is carbon, this is hydrogen. And last but not least, we have nitrogen, and that's 2.85 grams of nitrogen divided by 12.04 grams. And again, if you're wondering where I got that 12.04, it just comes from the problem above, or from the text of the problem, times 100. So 2.85 divided by 12.04 times 100, and I get 23.671% nitrogen. Now let's add these percentages up and see if we come very, very close to 100. We should. 60.963 plus 15.365 plus 23.671, and I get 99.999%. So if I add these up now, 99.999%, that's close enough to 100% for our purposes. You know, you're always dropping some decimals, and you have the potential to do some rounding errors. But this is percent composition. It's really straightforward stuff. Now I'm going to ask you to try one. So let me get rid of everything here. Get my eraser going. If I can do that. No, it doesn't want to do it. Come on, eraser. Microsoft, I hate you. Bill Gates, I hate you. No, nothing is working. You know what? That's okay. Because Microsoft and Bill Gates, he's the Antichrist. Okay, so I'm just going to move all that stuff over to the side, and I'm going to give you one, and we'll look at it together. Aspirin, which I've been taking lots of. It's bad grammar lately. It's a compound with the formula C9H8O4. C9, I don't know why I wrote that so far away. C9H8O4. So pause the video and come back and tell me what the percent composition of aspirin is. Okay, are you back yet? I hope so. Well, let's go ahead and do it. we've got the first thing we have to do is we have to figure out the molar mass of aspirin. And if you add up 9 carbons, 8 hydrogens, and 4 oxygens, you should get the molar mass is equal to 180.159 grams per mole. And now we're all set to go ahead and do our little thing here. The percent. Oh man, it's that Bill Gates again, trying to take over the world one mind at a time. I don't even know where my problem went to now. Okay, so back to the start here. We had C9, we had H8, and we had O4, and we know that the molar mass is 180.159 grams per mole. And going ahead, looking at this, percent carbon is going to be, well, I've got 9 carbons times 12.01 grams per mole divided by 180.159 grams per mole times 100. And hopefully you got, let's see, 60%. We got 60, not 6%, 60% carbon. And now let's do the hydrogen. The percent hydrogen is going to be 8 times 1.008 grams per mole, and that's divided by 180.159 grams per mole times 100 to give me my percentage. And if you go ahead and do that, you should get 4.476% hydrogen. And finally, we've got oxygen. The percent oxygen is going to be, well, I've got 4 of them, and I've got, each one is 16 grams per mole divided by 180.159 grams per mole. And I'm going to say, okay, times 100. And that's going to give me 35.52%. And that's my percent composition of aspirin. This is not so bad. Now I think I'm going to give you one to try. I want you to take a look at this compound, CuSO4 dot 5H2O. Now, if you remember what that was a hydrate compound, copper 2 sulfate pentahydrate, which means I've got 1 copper, 1 sulfur, 4 oxygens, 5 times 2 or 10 hydrogens, and 5 times 1 or 5 oxygens. I want you to find the percent. Excuse me. Pardon me. I'm on the sneezy day of COVID, apparently. Sneezy and cranky and Doc. I'm like 3 of the 7 dwarves. So I've got, I want the percent composition. That means what percent is copper, what percent is sulfur, what percent is oxygen, what percent is hydrogen, what percent is water. It's number 1. Then I want you to tell me what is the percent of this compound that is just CuSO4. In other words, what part of this compound, what percentage is just the copper sulfate part? And finally, tell me what percentage is just the water part. What percentage is water? When I get back, we're going to be doing this experiment and proving this, hopefully, in laboratory, your values. So when you do your math here, you're going to be halfway done because you'll have your theoretical calculations done. So I'm going to have you watch this video in class, And what I will do then, let me do it right now, actually. If I can, I'm going to pull up my OpenStax, get rid of my um, problem, and I'm going to ask you to go ahead. I think this is on page 144 in OpenStax. Let me see here. I'm going to go to science, once again, science, and we're going to go to our famous chemistry book, and let's take a look at table of contents. And we are going to take a look at this. And actually, if you'd like to read through, this is what I talked about. This is all percent composition, and there are some other examples here. Actually, I did a couple of the examples, but here's a little flow chart to show you how to get to where you need to go. And you can work through some of these other examples if you would like to. And this talks about empirical formulas. That's going to be for tomorrow, empirical formulas. Today, I just want you to focus on percent composition. So I'm looking at the problems in the back here. We were supposed to work through 1 through 20. So for today, actually for homework, why don't you go ahead and do a couple more, like 21 and 23. Okay, 21, 20. The answers are given, so if you just click on the odd answers, they're given. 21, 23, and let's see here. Let's do 33, 34, 35. I already told you a problem like 36 and 37. So 32 through 37. Or no, don't do 37. We're going to pick up and doing empirical formula tomorrow. So for the rest of class, work on those 32 through 36 and whatever ones I set up here. You can go back and watch the video again and get those down. But that's about it, guys. Spend the rest of the time working on that. Do them for homework. And then Wednesday, we'll talk about empirical formula. And by the time I get back on Thursday, you're all going to be experts. All right. So you guys have a great day, and I will see you soon. Bye.